Okay, so what we're going to do today is combine some geometry with more algebra and start looking at some new concepts in geometry. In particular, we're going to talk about how two lines can interact with each other in a plane. Now, what do I mean by that? Well, let's start with this. You have two lines. Okay, now, they're not necessarily in a plane, they're just two lines. What are the three ways that two lines can interact with each other? Good. They can be parallel, which means good. Perfect. Okay. Number one, and I'm not going to click because I forgot which order I put this in. Number one is they're parallel and they never intersect. They have nothing in common. They have no points in common. Train tracks, for instance, are parallel. What are the other two ways? Aaron, kind of. So in case you didn't hear, Aaron said perpendicular. Perpendicular is a special case of a more general situation. Tell me about two lines that are perpendicular. Bingo, stop. They intersect. Okay, so that's all we want. They intersect. And how many points do they have in common? One. Good. The third one is pretty tricky, and I don't know if you would get it because it requires 3 dimensions. So let's go through these. Number one, they intersect. Okay, which is why they clicked, because we had the intersection first. We've done that a lot, and we're going to do a lot with that. Number two, parallel, we're going to do that a lot today. Notice the symbol there. Okay, two little parallel lines means parallel because, again, we're mathematicians. Mathematicians are lazy, so we create a symbol for almost anything so we don't have to write things out. And then the third one, which, again, I don't think you would get, is what's called skew lines. Okay, what are skew lines? That explanation doesn't make a lot of sense, so I'll show you. Look up here. Skew lines are two lines that don't intersect but aren't parallel, so it requires a 3-dimensional thing. In a picture, it would look something like that. It's like a plane floating above another plane. Okay, so it's like the corner up there in the ceiling and a line on the floor. They're not parallel, because they don't run in the same direction, but they also don't have any points in common. We're not going to talk a lot about skew lines, but it is the third possible way that they can intersect. Or interact, I should say, not intersect. Okay, am I going too fast, or are we good? We're good? Okay. So we're going to focus today on number two. Eventually we'll get there, but we have to define some other pairs of angles. And you recall, when we talked about types of angles, we had 5 different types of angles. 0, acute, right, obtuse, and straight. Mainly acute, right, and obtuse. Then we started talking about pairs of angles. Give me some pairs of angles. There should be 5. What are they? Go.
Linear.
Good. Linear pair is 1. Adjacent is 2. Vertical is 3. Gesundheit. Say again? No, that one doesn't count. Supplementary and? Complementary. Good. Okay. We're going to get a ton of more pairs of angles today, and this can get kind of confusing. We've talked about those other 5 pairs. We're not going to talk too much about them today. We're going to look at these other different pairs. And these other pairs are, I think, a little bit easier to work with because they only work in a special scenario, okay, which we're going to talk about. So, before we move on, let's take a look at this picture. Right. Faye, just forget about the questions at the bottom. Just tell me what you see in that picture. Describe, so somebody walks in and says, "Hey, Faye, what are you doing?" How would you describe that picture to somebody? Thing?
Yeah.
Plane?
Yeah, the plane. And then line FJ is going through.
Okay. One small correction. Those lines are actually on the plane.
Oh.
They're not above, they're on the plane. Okay. So, did you all hear that? I know the fan is running, I'm sorry. Would it be better if I turned the fan off, or you like the air?
That's good.
Okay. What Faye said is we have a plane. That plane doesn't have a name, it's just a blue plane. There's 2 lines sitting on that plane, EG and KH. Elephant, gopher, and kangaroo, hippopotamus. And then we've got another line that she named FJ that's going through the plane. Perfect. Okay, which of those two lines are parallel? And that should be an obvious question, but so I'm not even going to wait for an answer. Do you see the two parallel lines? Okay, good. And again, because we're lazy, because we're mathematicians, we have a new symbol. How do I show that two lines are parallel? You'll notice the two little arrowheads in the middle of the line. The two matching arrowheads denote that those two lines are parallel. Okay, so that's our first type of interaction. Our second type of interaction, we have line ferret-jaguar intersecting line elephant-gopher at the point G. What's the fancy term for the point where a line passes through a plane? It's the foot, correct. Faye, back to you. Why is part of the line FJ dashed?
Because it shows it's
Perfect, yeah. It's hidden by the plane. And then the hard one is the skew lines. The reason the skew lines are difficult is because it appears that the line KH is intersecting the line FJ, but it's actually not, it's behind it. So those would be our two skew lines. And again, if you don't get the skew lines, it's okay, that's not important. What's more important is recognizing the parallel lines and recognizing the intersection lines. Okay, good. All right, so now we get into the nitty-gritty. We've got some new terminology. We're going to introduce this new term called a transversal. And a transversal is simply a line that intersects two other lines. That's it. So I have these two black lines. I drew another line through those two black lines and I called it T. And when you do that, you generate 8 different angles, which I've labeled 1 through 8. Don't get in the habit of thinking they're all going to be labeled the same. It changes every problem. Okay, so let's do some basic discussions here. Abe, let's start with you. Tell me the relationship between angles 1, 2, 3, and 4. Let's just focus on that point of intersection up on top. Pick any of the two angles and tell me how they relate.
Angle 1 and 2 are supplementary.
Perfect. Keep going.
3 and 4 are also supplementary.
Keep going.
1 and 4 are vertical.
Which makes them
Let's say.
perfect.
3 and 2 are also vertical, so they're also the same angle.
Love it. You got 2 more. Turn your head sideways. No. Turn your head like this.
1 and 3 are supplementary.
Excellent. Last one.
2 and 4 are supplementary.
Well done. Let's give it up for Aiden, please.
Yeah.
Any problems? A little bonus. Any problems with that? Okay, now, if I wanted to be silly, I could have him repeat that whole thing with 5, 6, 7, and 8. But we get the relationship then, okay? There's 2 points of intersection. The top one, which Aiden already talked about, and then the bottom one, which we're going to skip because I think you all get that. That has nothing to do with this. What we're going to do is we're going to pick one angle from the top point of intersection. Okay, in other words, 1, 2, 3, or 4. And we're going to pair it up with an angle from the bottom part, 5, 6, 7, 8. Okay, and that's what's going to drive our whole discussion today. An angle from one location, an angle from the other. Because the stuff that Aiden did for us, we've already done. We've talked about linear pairs, vertical angles, all that other fun stuff. We've got that taken care of. Now we're moving on to something new. Okay, so let's start with the basic one. These are called corresponding angles. They're called corresponding angles because they're in the same corresponding location around the points of intersection. So notice I've got these little mooing cows here. If I look at the numbers 1 through 4, I replaced 1 with a mooing cow. That mooing cow is in the upper left-hand corner of that point of intersection. The other mooing cow is also in the upper left-hand corner. Again, they're in the same corresponding locations. Are you with me? Good. In that case, where are the other corresponding angles? Yeah. Beautiful. 2 and 6 is another pair. 4 and 8. 3 and 7. Beautiful. Okay, we generate 4 pairs of corresponding angles. what that says there. Well done. And we can abbreviate that. In fact, if you're feeling fancies in your fancies, you can even get rid of the word angles and use the angle symbol. CORR angle symbol would tell you those are corresponding angles. And again, use the names to understand what angles we're talking about. They're in the same corresponding location around the points of intersection. The next couple slides are just going to be repeating this process, picking a point around the top point of intersection, picking a point around the bottom part of the intersection, and then seeing how they match up. Okay. Now notice, I didn't say anything about the relationship between those angles. All I talked about is what they are. Those are corresponding angles. I didn't say that they're equal, I didn't say they're supplementary, I didn't say anything about it. We'll get to that later. All right, next pair. Alternate interior angles. Okay, so before we even talk about the angles, let's break this down. Here are my two parallel lines coming through here. Do you see the part that's considered interior versus the part that's considered exterior? Yes or no? Or do you need me to illustrate it? Whoops. Come on, Reedy. You're better than this. Pen. Red. There we go. Interior part. Exterior part. Okay, make sense? Good. That's half of the name of that angle then. It's got to be on the inside between they're not parallel, between the intersecting lines. What does alternate mean? Well, alternate means on opposite sides of the transversal. Okay, so you see my little dancing stars there. They are satisfying both conditions. They're alternate because they're on opposite sides of the transversal, and they're in the interior. Does that make sense? Okay, good. Where's the other pair of alternate interior angles? There's only one other pair, by the way.
4 and 5.
4 and 5, well done. Okay. Now, before I go any further, you need to give me some input. Does this make sense? Any problems, or you need me to, because if this doesn't make sense, you're going to be screwed the rest of the lesson. And we don't want that to happen. So we're good. More so than ever, we want to use the KISS method here. Keep it simple, stupid. Break the name of the angle down so that you understand what we're talking about. And you're all fairly bright. What would be the next pair of angles? Alternate exterior. You probably have it in your slideshow, but it would have been better if you didn't have that in front of you. But yeah, alternate exterior. So again, break it down. Opposite sides of the transversal, but in the exterior. So the creepy unicorns that turn and smile at you are in those two locations. And it should be fairly obvious that 2 and 7 is the other pair. Are we good to go there? Okay. In case you hadn't noticed, corresponding angles, 4 pairs. Alternate interior, 2 pairs. Alternate exterior, 2 pairs. We're doing okay? Beautiful. Same side interior angles. Same side of the transversal in the inside. The swimming fishies. The other pair would be 4 and 6. All right, what's the last pair? Same side exterior. Get my clicker to work. Whoops. I don't know why that says CEA. It should say SSEA in parentheses. Got a little bit of typo there. Same side of the transversal on the outside. The other ones would be 2 and 8. Okay, so now, in the time span of 15 minutes, we jump from 5 pairs of angles up to 10 pairs of angles. Keeping that straight is going to be a little wonky. Any problems? Okay, we're going to change one small thing and then go through this again. What we're going to do is we're going to put restrictions on the black lines. So notice when I started all this, all we did is name the angles. Okay? Same side exterior angle, same side interior, alternate exterior corresponding. We talked nothing about how the angles relate size-wise to each other. Now we want to change the rules. So just to make sure we're on the same page, let's start with this. I got rid of the numbers. I don't want you to just memorize numbers. Jack, could you please tell me all the corresponding angles in that picture? We're going to use letters instead of numbers. M and E is 1. O and J, not to be confused with the murderer. SW, U and A. Perfect. John, how about my alternate interior angles? Oh, wrong. I'm sorry. Riku. Just call me John. I don't know why. That was awkward. That's okay. And? S and J, and the other pair is U and E. Well done. Okay. Lena, how about the alternate exterior angles? Good. Perfect. And last but not least, no, I lied. We got 2 more. Same side interior angles. L. Say again. E and good. Perfect. And last but not least, same side exterior angles page. And? Great. Okay. Any problems? Good. So really all we have to do here is be able to identify the angles. And this is starting a process that's going to make your life a lot easier. If you can do what we just did, the rest of this will be pretty straightforward based on changing the rules a little bit. And what rules are we going to change? Well, we're going to make the lines parallel. Okay? And I went back to numbering the angles just to make our lives easier. And we're going to go through this very methodically and see what we can come up with. Okay, so let's start with something easy. Annie, how big is angle? Let's start with 6. How big is angle 6? Tell me why. You got to talk loud. I'm right in front of here. If I'm going to do this, I'm going to do that. Sorry, everybody. Go ahead. Perfect. Okay. Let's go to angle 5. By the way, don't be bashful. Get out your calculators. I'd rather have you punch it in your calculator and give me the wrong answer.
It'd be 115 degrees.
Good. Tell me 2 reasons why that's 115 degrees.
Because 65, 180 minus 65 is 15, and then also angle 6 and angle 5 are something.
Good. Okay. And last but not least, how big is angle 7?
115.
Beautiful. Any problems there with anybody? Okay, notice that has nothing to do with what we talked about. That's just something we could have done 2-3 blocks, or okay, 2 or 3 classes ago. Okay, now things get interesting. Annie, in angles 1, 2, 3, and 4, do you have any idea how big those angles are?
No.
Would you care to guess?
Sure.
Okay. Well, hold on. Before you guess, I'm going to guess too. I'm going to suggest that that angle is also 115 degrees. How'd I do?
It's 65.
Why isn't it 115?
Because it's 2 is a corresponding angle to 65.
Good. Why else can 2 not be 115? What kind of angle is number 2? Can it be 115? Good. If you remember that simple fact, it will make your life a lot easier. Okay, so let me erase. So you're saying it's not 115. You're saying it's how much?
65.
65. Do you all agree? Okay, good. We'll talk about why that's 65 in a second, but I just want to finish the picture. Annie, finish this quickly for me. What's 1, 3, and 4 now?
1 is 115.
Uh-huh.
3 is 65 and 4 is 1.
Do we all agree? Excellent. Let's give it up for Annie. Now here's the great thing about this. If you look at that picture and the lines become parallel, there are only 2 angle measures in that picture. That's it. 4 of the angles are acute, 4 of the angles are obtuse. You need to keep that in mind when you're solving these problems. Okay? Can you all do that? Beautiful. It's not rocket science, right? So now we're going to explain why angles 1, 2, 3, and 4 are those values based on that other thing, using the angles that we talked, or the pairs of angles that we talked about earlier. Okay, so we did that already. Beautiful. Now, we're going to start with this. Now we're going pretty deep down the rabbit hole for geometry. So geometry in the old days, we used to do these things called proofs, which made students cry on a regular basis. We're not going to do that, but we are still going to bring some things in here which are called theorems and postulates. So before we move on, let's define those 2 terms. We'll start with postulate because it's on this slide. Okay. A postulate is something you're just going to believe me to be true. We're not going to prove it. You got to trust me on this. I don't have enough information to prove it, so I'm going to tell you it's true and you're just going to believe me. Here's a fun question. Can you give me a non-geometry related idea that you would consider a postulate? Say again? Oh, please explain, Jack. Say it loud, say it proud. Please explain.
Because you have to believe in your religion and
In particular in a God, right? Can you prove that there's a God?
no.
I'm not going to ask you if you believe, but people believe that there's a God. You can't necessarily prove it, so that is an excellent example of a postulate. And that's what we're going with here. Okay, I'm telling you that this is true. And we have to start somewhere, so you just got to trust me. Okay? And we already know that. I mean, Annie already used that to solve the last problem. We're going to assume that when the lines are parallel, and that's important, if the 2 lines are parallel, then the corresponding angles are congruent. Which is what Annie used to solve that monster. In fact, she even said, well, 2 is corresponding to the 65, so they have to be congruent. So she's operating a step ahead of us. Okay. In the red there is the abbreviation for this. Parallel lines, that arrow means implies. Parallel lines cut by a transversal implies that the corresponding angles are congruent. And there's 3 other pairs. I just chose 2 of them in that picture. Okay? So let's stop for a second, make sure we're good to go. If this makes sense, then the rest should be easy peasy. Because now all we have to ask is a simple question. How do the other angles relate? Okay, so let's go back to this picture. And we'll start with a simple question. Thanks. What other pair of angles would you like to talk about? Other than corresponding. You got to pick on one of the other 4. And I don't care which one. You can't get this wrong. But no, not those pairs. The pairs that we did today. Same side interior, same side exterior, alternate interior, alternate exterior. Same side interior. Beautiful. So could you tell me then which angles up here are the same side interior angles? Using the red angle numbers, not the 65 and 115. 3 and 5. Perfect. Okay, so we're going to focus on 3 and 5. She chose same side interior angles. She picked one pair of those, 3 and 5. So here's the question. How are those 2 angles related? Let's see. Talk about their measures. How do their measures compare? Also known as? Perfect. Do we all agree? Okay, beautiful. And we can play this game with all the angle measures. Pick any angle on that picture. For no particular reason, let's say number 1. And then pick another angle on that picture. Let's say 7. How do angles 1 and 7 relate? Well, the numbers are up there. It's an easy question. They're equal to each other. If you pick any two angles in that picture, they're either going to be congruent or they're going to be supplementary. No other options. That's what makes this nice and easy. It's a lot easier once you make the lines parallel. Okay, so now we quickly just go through all the theorems and do exactly what Lindsay just did for all the other types of angles. So if we talk about the alternate interior angle theorem, okay, and before we talk about it, let's talk about the word changing now to theorem. A theorem is something that can be proven. If I knock over this water bottle, it will make a loud noise. Can we prove that? Okay, we proved it. Oh, goodness, wow. So, why is angle 3 equal to angle 4? We should be able to prove it because it's a theorem. How do we prove it? And I'll give you a hint. Let's call this angle 2. How would I prove that angle 3 is congruent to angle 4 based on what we've already talked about? Take a shot at it.
Because it's an alternate side angle.
Okay, good. You haven't answered the question, though. Yes, the alternate interior angles are congruent, but why are they congruent?
Because they are the same number. Or they would be the same value.
Correct, but why? See, that's the problem with theorems, is that you keep asking the question why. But
The parallel lines. So,
yes, keep going.
the line like intersects that at the same angle.
Correct, keep going.
What's this now?
Fake.
3 and 2 are congruent, so
Okay, hold on, let me write that down. Angle 3 is congruent to angle 2. Do we all agree? Just for giggles, why are they congruent?
because they're vertical.
Outstanding, keep going.
So then 4 and the other,
I did that with my mind.
4 and the other angle are congruent.
4 and what other angle are you talking about? This one?
Yeah.
Let's call this 5 then. So you're saying angle 4 is congruent to angle 5, also because of vertical angles. Okay.
And they're like same side.
Oh, you're so close.
I don't know.
You're so close. Okay, so these are because they're vertical angles. I agree with you. So how do we get then, I'm going to put a dot, dot, dot in here. How do we get to angle 3 being congruent to angle 4 based off of what Faye has done? We're missing that one linchpin that will close this for us. Go.
Angle 3 and angle 4 add together to 180.
Good try though. What else? This is awkward. Go.
Angle 2 and 4 are in the same position.
Excellent. Which makes them equal. Very good. Angle 2 is congruent to angle 4 because, I'm going to use the fancy math terms, because they're corresponding angles. And if they're corresponding angles, they're equal because we did that here. That's where we had to start. Okay? So let's get rid of this for a second and just look at these two statements. Do you all see why this leads to this? Angle 3 is congruent to angle 2. Angle 2 is congruent to angle 4. Therefore, angle 3 has to be congruent to angle 4. Does that make sense? Okay. Sebastian and I are the same height. Sebastian and Aaron are the same height. What does that tell you about mine and Aaron's height? They're the same, right? That's the fancy term for that is the transitive property. I'll write that down. Transitive property. If two things are equal to the same thing. They are equal. And you can do height, you can do age, you can do weight, you can do all kinds of comparisons. Now here's the good thing about theorems. Once you prove them, you never have to prove them again. And that's why we implement this. We don't want to turn everything into a postulate because I don't want you to just blindly follow everything that I tell you. I want you to be able to understand where these things come from. So we've proven this AIA theorem. We're done with it. We never have to prove it again. So from now on, when I see this original picture, I notice that angle 3 and angle 4 are congruent because they're alternate interior angles with two parallel lines cut by a transversal, and the theorem says they have to be equal. Are we good? Can I move on? Okay. And we do that for all the other angles. And really, we're not going to do all these other proofs because you understand the basis of how I would do it. So for instance, if I was going to prove this one, I would call this angle 2, for instance. I would say angle 2 is congruent to angle 6 because they're corresponding angles. Angle 2 plus angle 5 equals 180, and then I would do some substitution. But what we're going to end up with is that the same side interior angles are supplementary. Okay, so now we get to the rant again about memorizing versus understanding. Yes, you can go home and memorize that same side interior angles are supplementary. You don't have to. Look at the picture. Is it possible for 5 and 6 to be equal to each other? No. One's acute, one's obtuse. We're done. And what we already talked about is, of the 8 angles up there, you only got 2 choices. They're equal or they're supplementary. So if they can't be equal, they got to be supplementary. The same thing holds for the SSEA. They're also supplementary. One's acute, one's obtuse. Okay? Any questions before we start bringing some algebra into this? Beautiful. Okay, there's the last one. Okay, those are equal. So the alternate angles are equal, the same side are supplementary. And again, you get that from the picture. I don't want to spend too much time talking about this. This is the one exception to everything we've done. This, instead of making the transversal at an angle, I drove it straight through the 2 parallel lines. And then it kind of it doesn't invalidate everything, but it makes things more difficult. Because notice, now all of a sudden I've got 8 90-degree angles. So those angles are both congruent and supplementary at the same time. Do I need to talk about this anymore? It's pretty straightforward, yes? Okay, good. All right, so let's move on to some algebra problems. What does an algebra problem look like? Well, we're going to solve some problems involving transversals, and you're going to be given some information about 2 angles. It's similar to... All good? Okay.
Yeah, I just get on it.
You do me a favor and bring the desk and chair in and put it against the wall there. Thanks. It's similar to the angles that the problems we did on the test and the quizzes and stuff where you've got the 2 lines intersecting. But now we have 3 lines with a transversal and everything else. And so here are some tips that are going to help you solve these problems. Okay? Now, what does that mean? You're going to be given 2 angles. The first question you should ask yourself is, what kind of angles are they? Are they all interior? Are they same side exterior, et cetera, et cetera? Step 2, you only got 2 choices. Are they equal, or do they add up to be 180? In other words, are they supplementary? Thank you. Number 3, write an equation. And number 4, make sure you answer the question. Plug in the value that you get for x or z or q or p or whatever the variable is, and plug it back in. Plugging it back in to answer the question also acts as a built-in checks and balances. I start the problem thinking that these 2 angles are supplementary because they're same side interior. I added them up, I set them equal to 180, I solve for x, I plug it back in, and 2 angles add up to 180. I'm good to go. Okay, so let's do this one then. Go ahead, you work. And there's a couple different ways you can solve this. So one of the things I want to talk about is not only what the answer is, but how did you solve it? All right, Pierce, you're up. What'd you get for x?
20.
Can somebody confirm?
Yes.
Excellent. What'd you get for angle 4, Pierce?
I got 55.
55, yes? Whoa, I don't know what happened to my 5 there.
No.
No, not 55.
Oh
Uh-oh.
shoot, I meant 125.
Okay. Yes?
Yes.
Okay, good. Pierce, talk us through it. How did you do that?
So I knew that the 125 was supplementary to 4.
Okay. And how did
no,
you...
No, I meant it was equal to 4.
Good. Okay, so right away you got this first.
Yeah.
Okay, I can take that. Then what?
And then I subtracted 180 from 25, which I got 55, and then I set 2x plus 15 equals to and then it's all.
I'm having trouble with my 5s today. Excellent. Okay, so Pierce did it that way. Let me reiterate. He knew... Oh, by the way, let's ramp this up a little bit. What kind of angles are those two? No, shh, Pierce. What pair of angles are those two angles?
Corresponding.
Excellent. Okay? So he looked at the corresponding angles and realized that angle 4 has to also be 125 degrees. Then he went back to the pairs we did the other day and said that this angle, the 2x plus 15, has to be supplementary to this because they're a linear pair. Set that equal to 55 and solve. Outstanding. Anybody do it differently? Yeah.
I did 125 plus 2x plus 15 equals 182.
Okay, so you took 125 plus 2x plus 15 and set it equal to 180. Why?
Because, well, 125 and angle 4 are equal.
Okay.
So, and angle 4 and 2x plus 15 equal 180. So I just
All right, bonus question. What pair of angles are those two?
put supplementary.
Yes. What pair of angles that we did today are those two? You may have to turn your head sideways.
Is it same side exterior?
Outstanding. Same side exterior. Okay. Now notice, you can solve this problem even if you forgot all 5 pairs of angles that we talked about earlier. You can still solve this problem not knowing that these are same side exterior angles. You can still solve this problem not knowing that these are corresponding angles. But at some point, you know I'm going to ask you, like, what kind of angles are those? Okay? Any problems? Let's give it up for Pierce. Well done. As the problems get more complicated, you're going to want to go back to those 4 steps. That should be your grounding point. If you're panicking, if you're freaking out, you don't know how to solve it, go back to the 4 steps. What pair of angles am I talking about? What's the relationship between the angles? What equation do I set up? Solve the equation, answer the question. All right, go. Tell me how big X and Y are. Oh, and I forgot to put an angle 3 up there. There's 3. There are a ton of different ways to solve this problem. You just got to figure out which one works for you and run with it. When you get an answer, check with the rest of your table to make sure you all agree. If you don't, start fighting.
Angle 3, I got 42. It's like, if you put up this one. No way. Angle 3, I got 42.
All right. I'm going to, before we talk about how you solve this, I'm going to ask a simple question. Well, it might not be a simple question. I'm just going to ask a question. What's the, I can't even think of the question. What pair of angles are those two? Of the 5 we talked about today, what pair of angles are those two that are marked? Nope. Anybody else? It's a trick question. Those aren't angles we talked about. Okay? But we don't need to know that because I can then ask this question. What's the relationship between those two marked angles? Bingo, they're supplementary. Okay. So they might not be a pair that you work on or that we talked about, but it is something that you can work with. Now, I'm guessing that most of you did not do 3x plus 9x plus 12 equals 180. Maybe you did. And maybe you did it by saying this. Well, I know that if this is 3x, this is also going to be 3x because those are what kind of angles? Say it loud, say it proud. Alternate interior angles. And now all of a sudden we got back to the stuff we did before. Those are supplementary angles. Okay? So, somehow we get to this. Blah, 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 blah. X equals, little help, 14. We're all in agreement there. Okay, what do I do next?
Okay, so you plug in 14 for 3x.
Okay,
plus-
14 times 3 is 42.
Yeah.
Okay, so that's 42. This is 42.
And you add 4y minus 10 equals 1. Yeah. Plus 42.
Plus 42 equals $1.80. Math, math, math. Y equals,
37.
yes, 37? Outstanding. And then last but not least, we want to find angle 3. Well, angle 3 is going to be 42 degrees because all of these angles, all the acute angles are 42. Okay? So you understand what I mean about the KISS method. There's only 2 possibilities. Please remember that. They're either equal or they're supplementary. You can't do anything else. And then you do some algebra. Okay. Now, one thing I didn't want to do, which might have happened, I don't know if anybody tried this, but this is also a valid equation. Nope. Sorry. Right? Now, why is that a valid equation? Those are alternate exterior angles. They're both acute. Sorry, I lied. They're both obtuse, so therefore they would be equal to each other. What's wrong with this? 2 variables. And one of the laws of algebra is you need the same number of equations as variables. Okay? So what would be your other equation? Well, then you go down this rabbit hole of 4y minus 10 plus 3x equals 180. Is that wrong? Absolutely not. But now all of a sudden I've created a system, and I don't want to solve a system if I don't have to. I would argue that the stuff that we did in orange is a lot easier. But different ways to solve the problem. If you panic, you've got some options there. Okay, questions? Does that make sense? Okay, good. That matches your answers. Now we introduce a special type of problem called the crook problem. Why is it called the crook? Because I took that transversal and I bent it in half. I put a crook in it, like a shepherd. You know what a shepherd's crook is? That's that stick, that the hook stick that a shepherd carries. Okay. So how do I do this? Well, the first thing I need is what's called an auxiliary line. I'm going to draw a line through that point of intersection. And that line's going to be special in that all three of those lines are going to be parallel to each other. Gesundheit. And this becomes a detective game here. I'm going to work from the top down, I'm going to work from the bottom up, and sometimes I'm going to work from the center out. I can't stress this enough. Notice I just sliced angle 1 into 2 pieces. Here's what I'm going to stress over and over again. Those pieces are not congruent. Okay. So let's label them for discussion purposes. That one and that. Okay. Have we done Greek letters yet? No? What? No? Okay, so here's the start. We're going to go with this guy. Fishy is an alpha. So we'll put a fishy down here, alpha. And then a beta, a B with a tail is a beta. Okay, the first two of the 24 Greek letters that we'll be using. So beta's here. And I'm going to write a little note here that alpha plus beta equals angle 1. Okay? Are we good with the setup? All right. So now I need to do some work. I need to figure out how big alpha is, and I need to figure out how big beta is. Damien, you want to give this a shot? Can you tell me how big either alpha or beta is? Or if you're feeling saucy, can you tell me how big both are?
How about no?
No clue. Okay, here, I'll help you a little bit. What if I do this? What if we forget about the top half of that picture? And I just look at the blue bottom line and the red line on top. What kind of angles are 144 and alpha? Good. So therefore, how big would alpha be? Wonderful. We're almost done. Everybody good on that?
Yeah.
Excellent. Okay, so let's get rid of this mess. Okay. Damien, back to you. If I take that same idea that I just did, and I erase or cover up the bottom part of this, what can you tell me about beta now? No. You had a 50-50 chance, so therefore how big would beta be? What? That's Lily. 62, why? No. They are congruent. What pair of angles are they? What pair of angles are the 62-degree angle and the beta? Good. That's half of it. Perfect. Alternate interior angles. That makes this 62. Okay. Even if she didn't know that those are alternate interior angles, she can still tell me that that's 62 degrees because they're both acute angles. Okay, that rule stays in place. Acute angles are equal to acute angles. Acute and obtuse are going to be supplementary. So now we answer the question. How big is angle 1? $98. Beautiful. 62 plus 36. Okay? So that is how a crook problem works. You start with that auxiliary line, which is going to break an angle up into pieces. They can look very different. In other words, I could start this same problem and tell you that angle 1 is equal to 98, and then ask you, get rid of this. Whoops. Hold on, Reedy. Get rid of this 62-degree angle and ask you to find that angle, for instance. Okay. You can work from the inside out, or you can work from the outside in. Most of the time, you're going to see go from the top to the bottom and bottom to the top, and then you meet in the middle to find that angle. Beautiful. We're done. Questions? There is a lot in this lesson. There's a lot of new terminology that you need to understand. There's a lot of angle pairs that you need to understand. But again, please try to stay with the KISS method. If you can't identify the types of angles, that's not the end of the world. What you do need to be able to do is identify the relationship between those two angles. Okay? Does that make sense? Any questions? Okay.